For this topic, there are a couple of different lung volumes that you need to know about and understand. So the graph we're looking at here looks at a number of different lung volumes, but the only two that we're interested in are tidal volume, which is represented by this blue line on the graph, and vital capacity, which is over here and represented by the red line on the graph. So if we start with tidal volume is the amount of air inspired and expired with each normal breath, and that could be at rest or during exercise. So as you take in a breath and then breathe out, the total volume of air there is our tidal volume. So on the graph here, we can see the blue line. This person is clearly at rest, breathing in and out, in and out. Over here, they clearly take a much deeper breath in because there's suddenly a spike in the curve before going straight back to normal and breathing in and out and in and out. If this person was to be exercising, so if they're at rest here and suddenly started exercising, the lines would get a lot closer together because breathing rate has increased, so there's more breaths, and they'd also get longer in size due to deeper breaths being taken in and out. So breathing rate and breathing depth would increase. Vital capacity over here. Vital capacity is the greatest amount of air that can be made to pass into and out of the lungs by the most forceful inspiration and expiration. So if you were to take in your deepest breath possible and then forcefully breathe out your deepest breath possible, that total volume would be your vital capacity. Vital capacity doesn't tend to change when we start exercising. So just because you're exercising doesn't mean you can suddenly get more air in the most forceful breath into your lungs. However, if you were to train for a long period of time, there's a chance that your vital capacity would increase. So if you were to start a running program for a period of 3 or 4 weeks and do a lot more running and cardiovascular work, you might find that your vital capacity actually increases as a result of that.
There is one other measurement that we need to be aware of, and this is Vo2 Max. Vo2 Max is the volume of oxygen an athlete can consume per minute while exercising at maximum capacity. This is measured in millilitres of air per kilogram of body weight per minute. A Vo2 Max test involves an athlete exercising at maximum intensity for a relatively long period of time on a treadmill or stationary bike. The athlete will wear a face mask which will measure their intake of air. When exercising at maximum capacity, the fitter an athlete is, the higher their Vo2 Max will be. Cyclists and marathon runners will have a high Vo2 Max, but the world record Vo2 Max for both men and women comes from cross-country skiers. This shows that cross-country skiers must have highly efficient respiratory systems in order to deliver large quantities of oxygen to their working muscles whilst performing.